Effect of fluorine in purification on the optoelectronic properties of chemical bath cadmium sulfide films. The cadmium sulfide is a semiconductor material with 2.42 electron volts direct bandgap at room temperature. It is considered of great importance due to its optoelectronic properties for photovoltaic application. CdS thin films have been used as window and N-type semiconductor in CdS CdTe. CdS films prepared by CvD usually present high resistivity. In order to overcome this, CdS films have been doped with several elements. In this work, semiconductor films of CdS impurified with fluoride were produced using the chemical bath technique. At two different temperatures growth on commercial glass FTO substrates, and the CdTe or cadmium telluride films were deposited by closed space sublimation or CSS to form a thin film heterostructure. We evaluate the influence of fluoride in different concentrations with a solar simulation by current versus voltage measurements. Electrical and optical properties were also evaluated. For the methodology, the CdS was deposited on commercial FTO substrates that were previously subjected to a cleaning process. The CdS deposits were made for 1 hour at 75 and 90 Celsius degrees with the concentration and volumes of the precursor shown in Table 1. Then, the CdS substrates from the previous step were used to deposit a CdTe film by the space close sublimation technique. The deposit was carried out under vacuum for 10 minutes. The deposit temperatures were 600 Celsius degrees for the source and 500 Celsius degrees for the substrate. Subsequently, the CdTe films were subjected to a common activation treatment with chlorine salts at 400 Celsius degrees temperature for 20 minutes. Finally, the subsequent copper and gold contacts were placed using the physical vapor deposition technique. Results. In Figure 1, the structural characterization of the CdS film is shown, carried out by Raman spectroscopy. The Raman shift indicates the presence of the first two longitudinal modes corresponding to CdS. We observe that the samples are slightly shifted towards a lower frequency compared to a raw CdS sample, this due to which is a thin film and is attributed to the effect of the surface optical phonon mode. In the literature, we find that the first and second longitudinal optical modes are in the frequency range of for thin films of CdS. We also know that the fluoride was incorporated in the doped samples because the Raman peaks, compared to the undoped ones, showed more shift and there were changes in their FWHM. In Figure 2, the transmittance spectrum for the CdS film is shown. For the couple of growing conditions of the CdS, we observe that there are percentage of transmittance little above 90%, perfect for a window in a solar cell. Figures also shown the graph of the estimation of the bandgap for the films. Values were around 2.3 and 2.4 electron volts, which coincide with that reported in the literature. Table 3 shows the electrical properties of the different films deposited by CvD technique at two different temperatures. The best electrical properties, such as the mobility, are 7 and 95, resistivity of 269, and a conductivity of 0.01697. These parameters were determined by Hall effect measurements. Conclusions. Undoped and fluorine-doped CdS thin films by CvD at 75 and 90 Celsius degrees were obtained. Raman spectra shows the vibrational modes characteristics of CdS and for the fluorine dope. Spectroscopy UV indicates that the optical transmissions of CdS and CdS fluorine dope is above 90% and the EG values were around 2.3 and 2.4 electron volts. The highest efficiency of the solar simulator was 7.47%. The solar cell with the best properties was the one that had grown to 75 Celsius degrees by CVD and 0.0025 molar fluoride. This cell has the smallest band gap with 2.34 electron volts, the best electrical properties that are shown in Table 2, and the efficiency of 6%. The incorporation of fluorine in small amounts improved the optoelectronic properties of a solar cell of heterostructure FTO-CdS fluoride dope CdTe.